Alright, hey, what's up, logicians? This is the first video on Venn diagrams, and just want to set up the basics of how we do Venn diagrams and what they're for. So, we've seen Venn diagrams in this class before, but we use them for a slightly different purpose. We used them when we were talking about set theory. Here we're going to use Venn diagrams for something else. And just to give you a quick overview of what they're for, Venn diagrams are used for figuring out the validity of certain kinds of predicate logic arguments, in particular arguments of this form. So these are called syllogisms. Here's one example. All humans are mortal. Some mortals are women. Therefore, some humans are women. And Venn diagrams are going to give us a visual way of checking whether or not arguments like that are valid or not. But before we can get into that, we need to figure out how to represent visually with Venn diagrams different sorts of statements. And the kinds of statements we're going to focus on are our four basic statements from predicate translation. And so I'm going to write those on the board here in just a second here to remind you what those are. So the first basic statement we have is the statement all A are B. We also have another basic statement. No A are B. And then we've got some basic statements. We've got down here, some A is B, some A is B. And we've got some A is not B. Those are our four basic statements, which you should remember from our predicate translations. On the Moodle site, that's lecture notes 12, if you'd like to look back at that. Now let's think about how we can represent these different statements with Venn diagrams. So consider this Venn diagram, where the first circle is A and the second circle is B. To say that all A are B is to say a certain region of our diagram is empty. There's nothing in that region. And the region that would be empty if all A are B is this region over here, this sort of moon-shaped region. Why is that? Well, the things in this moon-shaped region are the A's that are not B's. If all A's are B's, then there's nothing over there, because all of the A's have to be B's, so they must be over here. And so for doing these kind of Venn diagrams, we're going to shade out regions that we know for sure are unoccupied, that is, that are empty. And so in this case, we're going to know when all A are B, that region is empty. And so we shade it out. What about moving over here to no A are B? Well, let's draw our circles again. We've got our A circle and our B circle. And if no A are B, it means there's no overlap between A and B. Anything that's A is not B, right? And anything that's B is not A. There's none that have both properties. And so we know that the region that must be unoccupied is this region here. So we shade out the middle region. That's what corresponds to saying no A is B, or no A's are B. What about down here? Some A is B. So if we've got our A circle and our B circle, if some A is B, we know that there's at least one individual somewhere in this diagram. Where in the diagram? Well, we're saying that there's an A thing that's also a B thing. There's at least one A who is also B. So there must be an individual in the middle here. And to denote that, we use an asterisk. So think of that asterisk as saying there's something right there. Now, for all this diagram says, there might be things over here too, but we know for sure there's something in there, at least one thing in that region. Finally, some A is not B. We draw our two circles again, and then we need to think about where the individual would be. There's some A who's not B. Well, what region is that? That's that region of the diagram right there. So there must be at least one individual in that region, and so we draw an asterisk there. That's how we diagram our four basic statements. As you know from our predicate translations, these could be translated into predicate logic. I won't do that here, but that could be done. And just one more thing to note that's going to be important as we come to making our Venn diagrams for validity notice that these two statements are the negations of each other. And we can sort of see that visually, actually. This statement says that this A region is empty, whereas this statement says there's actually something in that region. So they're negations of each other. They're saying the opposite. And similarly, these two statements are negations of each other. And again, visually we can see that. This statement says that there's nothing in the overlap between A and B, and this says there's at least one thing in the overlap. So they're saying the opposite of each other. All right, that's it for the first introduction to Venn diagrams. Check out the next video for how we use this to evaluate arguments for validity.